already be intuitively familiar with the notion of slope, like the slope of a hill where you go cycling or skateboarding, or the gentle slope of a mountain traversed by a beginning skier versus a steeper slope an expert skier would choose. In math, we also refer to slope as the slant or obliqueness of the line, or its degree of inclination with respect to a horizontal reference line, denoted by an angle. Let's begin with a very simple equation for a family of straight lines, y equals ax, and examine the effect of coefficient a on the position of the line in the xy plane. We'll choose different values of a, graph the respective straight lines, and discover the impact of the coefficient. Before we graph, however, press Mode to check that function, connected, and sequential are all highlighted. Press y equals and enter the following equations. y1 equals 7x, y2 equals 2x, y3 equals 0.3x. For the next three, use the negative sign key in the bottom row. y4 equals negative 0.3x, 5 equals negative 2x, and y6 equals negative 7x. Let's graph these equations as dotted, connected, and thick lines by using different graphing styles. Use the arrow key to move the cursor onto the graphing style icon to the left of y1. Press Enter 6 times. Next, skip y2 and go to the left of y3. Press Enter once. Do the same for y4. Press Enter just once. Skip y5 and go to y6. Press Enter 6 times and you're done. Now press Zoom and select Zoom Standard by pressing 6. And there they are. The value of A clearly affects the inclination of the line. That's why we call A the slope. You can see that when A is positive, the lines rise from left to right. And when A is negative, they fall. And notice that when A is greatest and least, as in the dotted lines, the slopes are very steep. As A approaches 0, as in the thick lines, the slopes are very gentle. Let's generalize our findings. A, the coefficient of x, is the slope of the line. If A is positive, the line rises from left to right. If A is negative, the line falls from left to right. And lastly, the larger the absolute value of A, the steeper the slope. The smaller the absolute value of A, the gentler the slope. Let's explore further. We'll pick an arbitrary slope value, say 1.5, and keep that fixed. We'll then add different constants, graph, and see what happens. Press y equals and clear the previous equations. Then enter. For y1, 1.5x plus 9. y2, 1.5x plus 3.5. y3, 1.5x plus 0. You could just write 1.5x, but I want to emphasize that the constant here is 0. And y4 equals 1.5x minus 8. We're using the default graphing style, so keep track of which is which. Now press Zoom and select Zoom Standard again. Are you surprised that these lines are parallel? Press Trace, and you'll see that y1 crosses the y-axis at the point 0, 9. The coordinates of this point are displayed at the bottom. Press the down arrow 3 times and notice the y at each intersection point. Now we can generalize again and state finding number 5. Suppose line L1 has slope A1 and line L2 has slope A2. Then L1 is parallel to L2 if and only if they have the same slope. The double arrow, algebra for if and only if, is an equivalence. That means that both if-then statements are true, namely, if the lines are parallel, then their slopes are equal, and if their slopes are equal, then the lines are parallel. The two one-way arrows combine into one two-way arrow. Actually, results 2, 3, and 4 are also equivalences. Now go back to the parallel lines and call b the constant you added to ax to obtain the general form y equals ax plus b. You first saw that a is the slope. Then you discovered that b is the y value of the point where the line intersects the y-axis. This constant is therefore called the y-intercept. That's why the straight line equation is called the slope-intercept form. In different historical periods and various countries, other letters have been used for the slope and the constant terms. I like y equals ax plus b because it's the first member of a larger family of polynomial equations, all of which use coefficients a, b, c, d, etc., such as the quadratic equation y equals ax squared plus bx plus c, the second member of this family. Remember, though, that no matter what coefficient letters you use, the equations are all equivalent. The first term, which contains the slope, is called the linear term, and the second term, which contains the y-intercept, is called the constant term. The root of the word linear is line, so that's a logical connection, right? We began our exploration by graphing equations with b equals 0 and saw that they all went through the origin. Now let's try the reverse by graphing equations with a equals 0 and see what happens. Remember, we're in explore and discover mode, so we can try anything. That's how we investigate. That's how we learn. Press y equals and clear the previous equations. Then enter y1 equals 7, y2 equals 0, y3 equals negative 3, and y4 equals negative 8. Let's graph y2 as a thick line. Use your arrow keys to move your cursor to the left of y2. Press enter once and stop. Next, press zoom and select zoom standard. See that line graph onto the x-axis? If you hadn't used the thick line style, you wouldn't have seen it. Press trace. The y-intercept of y1 is clearly 7. Now press the left or right arrow. The y value is the same at every point of y1. That also holds true for the other lines. The y value remains constant and equal to the y-intercept. We confirmed that b is clearly the y-intercept, and we also learned that the equation of a horizontal line is y equals b, where b is a constant. In particular, y equals 0 is the equation of the x-axis. Since we just saw that a zero slope yields horizontal lines, we now recap the three cases. Positive slopes are equivalent to rising lines, negative slopes to falling lines, and zero slopes to horizontal lines. If the equation of a horizontal line is y equals a constant, because all points on the line have the same y-coordinate, then the equation of a vertical line must be x equals a constant, for the analogous reason. All points have the same x-coordinate. Visualize a vertical line crossing the x-axis at point 2, 0. All points on that line have an x value of 2, so its equation is x equals 2. So here's our final result. The simplest equation of a vertical line is x equals c, where c is a constant. In particular, x equals 0 is the equation of the y-axis. Beware, a vertical line cannot be written in the slope-intercept form because its slope is undefined. We'll see why in the next exploration.